Here into the research views, so I welcome Gustavo to present the 5G research view of CPqD.
Good morning, all. I'll present a vision on 5G technology. I must say that I'm not as an expert as you are on the data network, the slice in the core of the network, but more on wireless technology. But I'm trying to bring a vision of what we see here as 5G as a whole, okay? Well, I won't put here, but in CPqD we have a strategic teams, and 5G is both on our protagonism on IoT and the connectivity strategic team, okay? Again, how CPqD works with knowledge. We have three technology platforms that deal with connectivity technologies, and also information security is very important today for any operation on telco or ICT. Well, 5G was brought to us as an ambitious vision that its point on the document from ITU. It's a wireless infrastructure to connect all the world. That brings people and machine to the connectivity place. I guess everybody knows the triangle that you see in every presentation about the three pillars of 5G. It's ultra reliable low latency communication, WLC, that's bringing us a new technology that we didn't have access so far on wireless communications. We see this as a major topic, that will bring a new use cases for us, that will change how we as a society use this technology. The enhanced mobile broadband, it was the first use case that is known for all of us, the need to bring more data throughput to the systems. There is a bottleneck in the internet nowadays because we have almost a prediction to have almost 80% of the traffic in internet as video, not only produced by people but also by machines, okay? And there is also the other pillar, that's Internet of Things, that everybody's talking about. It has been here for some time, but 5G is seen as a catalyst for the transformation, the more dissemination of IoT, okay? Well, as I said, it's a multifunctional platform. It brings some use cases and requirements that are very different from one another. So we have from wideband communication to situations where we have narrowband communications, as in IoT. We have mission critical, flowing the same physical infrastructure that is prepared to work with nominal traffic. You can't allow a critical service like first responders communication to conflict with communication from the normal user that's watching Netflix. So to have this on the same physical network is a challenge, and 5G will deal with that. We come to the solutions that come from high to no mobility. You have use cases where fixed wireless access is as much important as is to provide communication to vehicles or even to airplanes. We come to the place where you have from wide area coverage to hotspots, and it's going to happen a lot on the cases of high throughput. Something that was already here on 5G, in 4G, it was the device-to-device communication, a mesh or a relay network, but in 5G it was born with this in place, okay? The technologies, it's not worth to mention, FDD, TDD, half-duplex, licensed, share and unlicensed access. Today we have spectrum. Spectrum is the pipe where wireless communications flows through. And this is a scarce resource. So as we evolve in the technology, it was necessary to go from the spectrum bands we have now to places in the spectrum where we have more availability. And also, there's a huge concern to use the spectrum that is most suitable to use for coverage, the lower bands, as a shared infrastructure. I won't bring to the point here where we evolved from the 4G to 5G. It's the OFDM from adapted to extremes, massive MIMO. Again, what we bring here is that from what we evolved from, what was 4G, what is 4G right now, okay? We started this as an evolution from communication from people and trying to cover as many people as you can. But when you bring too much people to certain areas, and with the growth in the demand for data, we see that we are now facing some challenging situations where you cannot provide or guarantee bandwidth to everybody. So let's suppose an event where you go to a stadium to watch a show, and everybody today brings their cell phones and start to shooting the show instead of watching the show. Okay, it's a cultural change, but for the networks, it's hard to support everybody streaming live video in the network. So you have a need for data throughput that is going to be addressed by the millimeter waves that has more capacity to address that. But it's contained on a small area, so that's a typical use case of hotspot, okay? We have now different kind of use cases like vehicle communications. They won't demand too much data, but it will demand low latency as a critical service, because we're talking about communication of vehicles to avoid collision. You cannot see the traffic the same way you see someone using, again, WhatsApp. From the IoT side, we will have a lot of use cases, and some of these use cases will demand a large coverage area. So it's a different use case, different requirements, and we are talking about the same infrastructure, the same physical infrastructure. What 5G brought to us as innovations, there are the 6 themes here. The new spectrum and bandwidth, massive MIMO and beamforming. It also brings us more capacity to each cell, especially on the millimeter wave bands. So right now we can have much more elements in the antenna than we had with the lower bands. A lean design, that's something that's very crucial for IoT. You want to have your IoT device powered with batteries to last this battery for as long as 10 years. There is also one thing that's very interesting for the operators, because the CAPEX, the OPEX for the operators has a large part, it's the consumption of energy. So the lean design of 5G is important for that. We are talking about here about the network slicing. That is a use case, not as a use case, but it's a feature that's crucial to use for diverse requirements and use case. This one here is the feature that allows to use the same physical infrastructure to address a lot of use cases. CUPS is here since 4G, since release 14. It's the control user plane separation. But again, we're talking about network slicing, SDN, and that is something that must be seen as a crucial technology here for 5G. And multi-access edge computing, it's one of the things that will allow us to work with ultra low latency communications, okay? Ultra reliable, low latency communications. Because you bring the power of processing the applications closer to the network station, to the tower. So here we can have the low latencies we are talking about. What is the network evolution we're seeing right now? We had an architecture where the BBU was located close to the towers, and there was, it's not that there wasn't a communication between the towers, but it was limited. So things like cooperative multipoint, comp, was not there. You couldn't use that as effective as you can with central run. Central run shares more information between the base stations, and you can have in some certain area to avoid like interference from neighbor cells. And we're now talking about an evolution to cloud run, where we will have a central processing of all data. There is a resource inside the RAN that is called Radio Resource Management, where you try to avoid collisions or interference from one user to another, and that with that integration of all cells, you have more, it's more easy to process the data and avoid this kind of interference, to have more capacity on these networks. There is also the integration of the services, the multi-access edge communication, that will bring us a lot of new use cases, new applications. I have here another design of the RAN, where we can see how we are evolving from a distributed architecture to a more centralized architecture. And there is a different aspect here, something that has been in discussion even in 4G, the split of the network stack for the RAN, where you have some part of the processing closer to the cloud, it's allowed to you, and something that is more critical about the latency close to the antenna. Again, when we talk about Cloud RAN, we're not talking only about the virtualization of the RAN, but we are talking about the NFV, SDN for the transport network. Cloud RAN is a new architecture we are looking at. And that together will bring us to telco cloud, something that the operators see as, I think, very interesting for their work. The network virtualization advantages is that you have now the ability to put more agile transformations to your network and offer different services as short as in 18 months, when you had in the previous generations, from 3 to 6 months to have a new features on your network. That is an agile operation for you to offer new services. With orchestration, we hope to have something as close to put something in operation on demand. When you have a customer, you get a new requirement or use case, and you can provide that slice, you put here as a slice, target to this application. Again, how we are addressing the cups in the core network. This is the architecture of the core network of 5G. Network slicing, you see here, is it a critical feature to address different use cases from automotive, medical, and infrastructure that are mission critical, to something that is more to mobile broadband slice, communication, entertainment, and internet. Again, to address different use cases from different markets, the vertical markets are expected to bring the revenue that telcos are seeking right now, because it's stagnated, the revenues from the business-to-consumer model. End-to-end latency, how it's today on 4G. You have to pass through all this chain here to go to the cloud and have your data processed or your request to have a feedback. So we have all these steps here. With the multi-access edge computing and the cups, the separation between the control and the user plane, you can have the, let's say, the data plane as close to the user as the distance from the tower to the user, okay? The latency impacting AR, VR, I'll bring more speed here because my time is over. Optical networks, and one thing that's very trendy for 5G, it's the concept of disaggregation from hardware to software. So we have a lot of projects right now ongoing. We see this. We have here in CPqD, we are a TIP community lab. So we have all the some of these projects here on running right now. And there is one here that is very interesting for everyone that's working on the network slicing or the cloud slicing. It's a project called end-to-end network slicing. It's part of the TIP project, okay? Again, CPqD is one of the TIP community labs in the world. And this is the end-to-end network we have right now in CPqD. We're going to show that in FutureCon, where we are trying the Open Run concept that has the virtualization of the run, also the disaggregation of the transport network, and the edge application development, where we will have some multi-access edge computing apps running on this network. This is the site here in CPqD where we'll have this test bed working, okay? So it's open. I invite everyone that is interested in trying your use cases here with us. I won't talk about 6G, but we are seeing that the roadmap is closer, as Professor said. We hope to have some discussions on 3GPP starting 2025, I think. The discussions start about what would be 6G. So we are very interested in see what will bring us. I still believe that 5G has a path to go. It will be a long-term evolution like 4G was, but let's keep an eye on this. Thank you very much.
Okay.